What if Mars could become our second Earth? What if deserts of red dust could turn into oceans and skies, with life breathing under them? This is the science and the struggle of terraforming Mars. In 25 facts. Mars is the only planet in our solar system that feels almost habitable. Mars is about half Earth's size with gravity at 38%, just enough for humans to walk but not float. A Martian day, or sol, is 24 hours and 39 minutes, almost the same as Earth's. Mars has seasons, polar ice caps, and weather cycles, but its atmosphere is 100 times thinner than ours. That thin air is 95% carbon dioxide, good for plants, deadly for humans. Its average temperature, minus 80 degrees Fahrenheit. That's colder than Antarctica. Mars is almost Earth-like, but almost isn't enough. To terraform Mars, we'd need to change the planet itself. The dream of terraforming Mars isn't new, it's decades old. In 1964, Carl Sagan first proposed altering Mars' climate with giant orbiting mirrors. Later studies suggested seeding Mars with dark dust to melt its ice caps. NASA scientists in the 1970s imagined using nuclear explosions to kickstart warming. Elon Musk revived that same idea in 2015, sparking global debate. Even so, every method faces the same question. Does Mars have enough atmosphere to work with? Mars isn't just stubborn, it might be impossible to remake, and that's before you consider how to actually heat a frozen planet. Terraforming begins with one problem: Mars is too cold. Scientists estimate Mars would need an atmosphere 10 to 20 times thicker to trap enough heat. Melting Mars's polar ice caps could release trapped carbon dioxide, kickstarting a greenhouse effect. Studies suggest this might raise temperatures by 10 to 20 degrees Fahrenheit, but not enough for oceans. An alternative? Orbital mirrors, hundreds of miles wide, focusing sunlight onto the surface. The most extreme idea: fusion-powered factories pumping greenhouse gases directly into Mars's skies. To warm Mars, we'd need the largest engineering project in human history, but warmth is nothing without air. Terraforming begins with one problem: Mars is too cold. Right now, Mars' air pressure is less than 1% of Earth's. You'd suffocate instantly. Terraforming would require raising air pressure to at least 19% of Earth's sea level pressure. Plants could grow in carbon dioxide, but humans would still need oxygen tanks. One idea: use genetically engineered microbes to slowly release oxygen. Another: redirect ammonia-rich asteroids to crash into Mars, thickening the atmosphere with nitrogen. Even if we could breathe on Mars, it would take centuries to make it happen. And then comes the hardest part: keeping it that way. Terraforming Mars isn't a project, it's a gamble against nature itself. Mars lost its original atmosphere billions of years ago, stripped by solar wind. Without a magnetic field, any new atmosphere we create might leak into space again. Some scientists propose building a giant magnetic shield at Mars' L1 point to protect it. Terraforming estimates range from hundreds to thousands of years, if it's even possible. But here's the twist: many experts argue terraforming is a distraction, and instead suggest building domed cities and letting Mars stay Mars. Terraforming isn't just science fiction, it's science on the edge of imagination. And here's the twist: by the time we're ready to terraform Mars, climate change might have forced us to practice terraforming right here on Earth. The question isn't just can we do it on Mars? It's whether we can do it at home before it's too late. Love space, science, and the future of humanity? Don't forget to like, subscribe, and share as we learn more together.